welcome to the third edition of the August 2012 News Roundup of the Amazing World of Psychiatry blog. In the news today, there is a new approach to diagnosing epilepsy which can identify evidence of seizure activity after the seizure has happened. This approach has been developed by a team at the University of Minnesota and the Mayo Clinic. Amongst the innovations, they have used 76 electrodes compared to the usual 32. And as a result they've got more data points in their analysis. They have a press release at the University of Minnesota website as well as the advanced publication at the journal. The study was relatively small with 28 people with temporal lobe epilepsy. Their main findings were that increased slow wave activity occurred in the frontal lobe in people that had complex partial seizures and seizures with secondary generalization when compared to simple partial seizures. They were also confident that this approach could be used to identify which side of the brain, the left or the right, the seizures originated in. There's a video in the post so you can see Professor Hebin explaining this new approach. And remember, this is in the research setting at the moment, so this is not in clinical practice routinely. In another study which has been generating a lot of interest, researchers found evidence that older fathers may be passing on more mutations in their DNA to their offspring, and that this may be associated with autism and schizophrenia. So we have to be slightly careful about this analysis. First of all, this was an Icelandic study, and Iceland is known for having a very well characterized population. They've got very good genealogical data, so they've traced out the family relationships going back quite a long time. They followed up trios of mother, father and child and looked at their DNA, and what they were interested in was de novo mutations in the DNA. That means when there was a DNA change in the baby, something that was not present in either of the parents. And what they found was that the more mutations there were, the more likely the father was to be of an older age, and this was a significant finding. The age of the mother wasn't so significantly correlated with this. Now, it's slightly difficult to go from this finding to then saying that older fathers would be more likely to have children with autism and schizophrenia. The other bit of evidence they had from this study was that some of these new mutations had occurred in genes that have classically been associated with autism and schizophrenia in previous studies. So it's a little bit more evidence, but it is still circumstantial. So what we have here are associations, and it's important to bear that in mind. It's certainly evidence for the hypothesis, but I think the debate needs to be continued, and perhaps the really useful point about this study is that this debate is now happening. In other news, a private genetics company, 23andMe, is looking for new genes associated with Parkinson's disease, and they're recruiting people for their study. So this is a move away from the government-funded studies to private enterprises that are taking a central role in genetics testing. In another study, increased sleep at night and increased slow-wave sleep were associated with improved performance in working memory tasks in people with Parkinson's disease. This was a small study with 54 people in it, but there's a lot of other literature in the general population supporting a strong association between sleep, quality of sleep, the length, duration of sleep, and impaired cognitive performance. There is a new nanoparticle that has been generated using a combination of chemicals, including carbon. There's been an interesting study about a new compound that's been created, which has properties that include free radical scavenging. Free radicals are particles that are produced by oxidation as a byproduct of energy metabolism of the energy producing metabolic processes, and these free radicals are thought to damage the cells and parts of the cells and cause a lot of damage in the cells and tissues. So this new nanoparticle was found to significantly reduce this, and in a model they were examining also significantly influenced cerebral blood flow. So this is a very exciting finding. There's also another exciting finding, which is the discovery of the so-called glymphatic system. So what researchers did was that they looked at a murine model and used a radio-labelled compound to investigate how the brain clears materials. And what they found was that these compounds moved towards the venous drainage in the brain to a parallel system which was facilitated by the glial cells, which are support cells in the brain, and it was this system that helped to remove material. So the researchers were thinking maybe this might be relevant to diseases like Alzheimer's disease, where there's a build-up of amyloid plaque in the brain. There's a link to a YouTube video by the research team which discusses these findings in a bit more detail. There's also an interesting list, which is certainly worth a look, of the 20 most watched TED episodes, which includes titles such as Why Are We Happy?, Brain Magic, and Why Do We Do What We Do? So I've put links to all of those three in there, and there's also an inlay link to the video about Why Are We Happy? And that's extremely entertaining as well as instructive. In the evolutionary psychiatry section, there's some new evidence that Neanderthals were able to speak. This is important because there's evidence that humans and Neanderthals interbred, and that they contributed a few percent of our modern changes on the right hand side, which is also consistent with analysis of the teeth in another study. So what this is suggesting is that Neanderthals may have been right-handed quite commonly, and there's also a theory that handedness is related to language and that you need asymmetry in the brain for language. So this is an interesting finding. In another post, another blog, there's a very interesting post about some new studies in brain evolution, which is well worth a look. And this includes differences in gene expression in the frontal lobe between humans and chimpanzees, as well as gene methylation differences between humans and chimpanzees. And this is the field of epigenetics. So what happens after you've inherited genes to the genes and their gene products. You can find these stories on the Amazing World of Psychiatry website, which can be found at theamazingworldofpsychiatry.wordpress.com. There are a few things on the website that you won't find here, for instance videos by other people or links to videos by other people, and also there will be hypertext links, so you'll be able to navigate to the source for these news items.